All right, great. Thank you very much. Yeah, it's been said, I'm Russell Bryant, and I'm here to talk about the state of OVN, at least from my perspective. And so as a place to start, I kind of want to give you some context of what my perspective is, so it kind of explains all the things I'll say after this. The first way to explain my perspective on OVN is as a contributor and committer to the OVN project. My involvement started early in the OVN project when Ben and Justin put out the proposal for doing the project and the initial design documents, and we started talking through the design and then writing the first lines of code. That's when I got involved. That's when I was looking for ways to pitch in, and I've been contributing since then. Also as an OpenStack person, so I've been deeply involved in different parts of OpenStack since late 2011. I've been a contributor and committer to different parts of OpenStack along that time, primarily in the compute and networking areas. And so when I got involved in OVN in parallel with the core OVN work, I was launching the integration with OpenStack as a part of that, kind of work on it in parallel. And lastly, my role at Red Hat is I work in the CTO office. So I'm not just looking at OVN as by itself, and I'm not just looking at OVN as solving problems for OpenStack, but I'm concerned with a broader technology strategy for Red Hat. And OVN has to solve more than just OpenStack problems. It needs to be solving problems beyond that, both now and into the future. Otherwise, this isn't worth our effort. So that's my perspective and where I'm coming from. And I kind of want to focus today really looking at this from an OpenStack perspective, because I think it helps to look at to think about the state of the project. Let's talk about what problems it has solved and how it's going to do that. And I can do that at least from a perspective about OpenStack. So my start was with OpenStack as the consumer. And what did I want to solve? What did I think we might be able to solve with OVN for OpenStack? First of all, it needs to meet the functional requirements. I mean, Neutron was well established at this point, has a ton of features, even had existing OVS integration. And so we have to do all the same things, but why would we rebuild it? It needs to be reusable outside of OpenStack, so that's kind of a key piece, right? So can we do something that works for OpenStack that actually is useful to us beyond OpenStack, or more useful to us beyond OpenStack? So that's a key part. But to do it, it's got to be really easy to integrate with, because we had a really big list of things to catch up with, right? We started from nothing. And we're looking at a project that had a whole lot of existing stuff, and we had to catch up. For this to provide us any value, we have to catch up and exceed it and provide real value above and beyond what OpenStack was already doing. So it better be easy to integrate with. And really, one of the really nice things about the existing OVS integration with OpenStack is that's what it came with it, right? Like from a operator perspective, you install OpenStack, you get this stuff with it. It's not a separate, complex set of software that you're installing. And OVN, while we're building it outside of OpenStack, it needs to sort of feel that way as best we can. Like it needs to not feel like it was something really big and complex that we're adding. And so part of that is really minimizing the dependency set, and I think that's something we've done. So off we went, and the project started early 2015. So one of the first things you need is layer 2 virtual networks. And so a Neutron network is equivalent to an OVN logical switch. And this actually happened really fast. We went from 0 lines of code in OVN to being able to ping between 2 VMs over a virtual L2 network in 6 weeks. We're pretty proud of that. Demoed it at OpenStack Summit. And looking back, I saw that we actually had the container within virtual machine modeling for virtual networking that early, which was, I think, really cool that we had that far back. What was different? This was all OpenFlow, which is different than how OpenStack did this stuff before. Maybe not hugely valuable at the time, but it was a really important building block for all the things we would come to do later. And it also started to show how we're going to start replacing the OVS integration, right? So we have an agent called OVN controller that runs every host that replaces the OVS agent. But even that early, you could start to see how we'll do some things different. There's some features that were added to OpenStack along the way that taking the fresh look at it, like we're just going to make it the way it works. It's not. Some things don't make sense to be optional. They shouldn't be included in the feature matrix. Things you decide to turn on and off, or the feature metrics you test and deal with, whether features work together or not. And one of those in the OpenStack OBS integration is the local ARP responder. It's called L2POP in OpenStack, and that's like a thing people have to think about and worry about whether it works with other features or not. And OVN just does this because that's what it should do. Security groups. We need to be able to define security policies with OVN, and the way OVN provides that is with ACLs. This is a distributed firewall implementation. This was in place by fall of 2015, and it's built on top of OVS contract integration. This is more efficient than the way OpenStack originally did security groups, which involved IP tables usage. More recently, OpenStack has a new firewall driver called the OVS firewall driver, which is conceptually similar, but kind of starting to show the value of reuse. Like the way OVN did this with ACLs, it's actually far more flexible than what security groups needs, and it's great. And so we're able to do our security groups work, but we were already seeing ACLs used by other integrations successfully, and I think that's proved to be a good interface for what we needed and what other people need. And a more recent addition to this is logging. So you can now specify on a per security policy basis that when that policy is hit, whether like if it's a connection that's rejected, you can log that, or you can even turn it on for all the connections you're accepting. Like for an auditing purposes, if you want to do that, you can do that too. And I think that's a good example of how we can start to add value and above and beyond. So that's a recent addition. We need logical routers. This is continuing to sort of our charge towards feature parity. A neutron router is equivalent to an OVN logical router. This was in place pretty rapidly, pretty quickly. This is by fall of 2015. It's fully distributed. Again, in terms of the difference and the value we're starting to add, like it's distributed because that's the way it should work. This is not something optional. You don't have to worry about it or think about it and deal with this as an element in the feature matrix of may or may not work in combination with other things. So that was a nice simplification for OpenStack. It's implemented all using OpenFlow. So this is OVN controller, the one daemon we have running on every host, starting to replace the job of the Neutron L3 agent. And the way this is implemented provides some performance improvements. We calculate routing and the end result of that, and it gets cached in the kernel, which is more efficient than the method that OpenStack used before, which is wiring up Linux network namespaces to do the routing. So every packet is going through namespaces. We're able to cache the end result of our routing decisions, which is just changing source and dest max and decrementing a TTL field and cache that in the kernel. Another nice change is it actually works with DPDK versus the other approach that doesn't. So yay for that. On we go. Another fairly early feature was L2 gateways. This is the first gatewaying technology that was added to OVN. And by fall of 2015, there was hardware VTEP L2 gateway support. And this is interesting to OpenStack. This is not really a primary way that OpenStack does gatewaying, but it's a good example of how OVN is starting to provide features that maybe OpenStack wouldn't have had. There is we had this proof of concept integration that's still there, but we still haven't done the proper OpenStack API integration with this, which is the L2 gateway API. We could still do that, but haven't yet. And then we did also add software-based L2 gateway support that OVN controller will do on a general Linux host later on. And then we hit the first release, so 2.5. That's February of 2016. And it was an experimental release, so it was included in 2.5, but we knew that there were still enough feature gaps that call it experimental. Provider networks. This is another critical feature needed to do what OpenStack needs. This is mapping a physical network into OVN's model. And the way we do this is you have a logical switch with a special local net port. And it supports flat or VLAN networks. And you can attach ports directly to this network. That's not hugely interesting because we're not actually doing virtual networking at this point. OVN, you can still use OVN to define and manage and implement your security policies in doing that. But the real reason that this is really important is we need to be able to map physical networks into the system so that we can gateway to them. So this was a building block to then get to the L3 gateways in particular. So that brings me to L3 gateways, and this was a really important one that we got to in 2016, and we got L3 gateways between the logical overlay networks and physical networks. This included NAT support, and like everything else in OVN, this is done natively in OVS, built on top of the OVS contract integration. From an OpenStack view, this does both the SNAT function and floating IPs. And it's defined in OVN pipelines, implemented in OpenFlow, and provided us with performance benefits beyond the ways this was implemented in the past. Load balancing. This is a good example of OVN, evolving in its own right, supporting more than just OpenStack and providing value, not just in terms of matching what we were doing with OpenStack, but doing new things. OVN has a native distributed layer 4 load balancing. This was really driven by the Kubernetes integration, but it's very valuable to OpenStack, and we're actually just now finally getting around to doing integration with OpenStack with this. So the default way that the load balancing service in OpenStack would work is that it'll create a service VM and run HA proxy in there. But if you're doing layer 4 load balancing, once this is done, we'll be able to program this in OVN, and it'll be drastically more efficient. OVN tracing. Anything we can do to make debugging easier, so you have some issue, and anything we can do to make it easier to get to the root cause of that faster is really beneficial. I mean, it's certainly helpful for development or learning the system, but above all, when operating the system. And so OVN Trace has been a very useful tool in that regard, and it's been enhanced in releases since it was first added by Ben. But it allows you to trace a sample packet through OVN and see how OVN thinks it should be processed based on how you currently have it configured. Several different layers of detail, but the key thing is that it lets you start to figure out the behavior of the system at a higher level. So you don't have to jump as quickly into lower level debugging or looking at OpenFlow. You can more quickly determine if the problem was your config. So traffic's not being processed how you expect. Go ask OVN Trace what it thinks should happen. If it says, well, the traffic's going to be dropped because that's what you configured it to do, then you found that out a whole lot faster than you would have otherwise. So it's an incredibly helpful tool that's really something that we didn't have before. So it's again another example of how OVN is starting to add more value. DHCP. OVN has some native DHCP support. It's sort of minimal, and the intent is to do the bootstrapping of VMs. So we were configuring the system with IPs. So OVN knows what the IP is going to be for a VM. So when a VM comes up and sends its request, we can intercept it and send the response locally. So this is sort of a distributed thing that OVN controller does. Like everything else in OVN, we have that one daemon that does it. And from an OpenStack perspective, this is replacing yet another agent for us. So another Python agent we don't have to use anymore. That Python agent managed DNS mask processes to do this. And on a higher, on a bigger system, this could be hundreds or thousands of DNS mask processes across different hosts. And so that's all gone, and OVN controller takes care of that. So big simplification of OpenStack. We hit OVS 2.6, and this we called our first supported release because we felt like we've now have the major pieces in place. We know we can continue to do more work, add more things, but we're going to start seeing more. It's more polish and improvements as opposed to this giant feature gap. Like we're missing L3 gateways. Like we had kind of gotten over that hump, and we're starting to improve and polish things. Off we go. Now we're starting to hit this year. So we had our next release after that is OVS 2.7. Like I remember in this time frame, I spent a ton of time doing performance testing, control plane and performance and data plane testing. It was kind of we've done a lot of work. We've done testing along the way, but let's do like a really, really deep set of testing and make sure we know where we are and have an idea of where we need to improve. And that was helpful and validated that we were in good shape. There was, sort of as a polished thing, there was a lot of work went into simplifying router and gateway modeling. It made our integration with OPENSTACK a lot easier because it allows us to more easily combine the roles of distributed east-west routing and the centralized gateway routing that involves NAT. We can just configure it a lot easier. Some QoS support got added. That's more feature parity stuff for OPENSTACK that we make use of. Source IP-based routing policy added for L3 gateways. That's a really nice thing. We're still not making use of that from OPENSTACK. We could, and I think we should, but that got added there. OVN trace got more enhancements. SSL config simplified. I mean, we start to get to production use. SSL is used everywhere, so we started to see ways that we can simplify that. And then OVS 2.8. That's not that long ago, and the oven is really cooking. We started continuing to polish what we've got. L3 gateway high availability, I'll talk a little bit more about that in a second. That got added, that was a key thing. So we had gateway support the year before, but the next level of that is let's make them automatically highly available. So that got integrated, and that's done natively by OVN, not adding extra components. Native internal DNS support, again, chipping away at the things that we have to do externally and adding to what OVN can do. That was another feature that we needed in OpenStack that now OVN takes care of us. So it's continuing to make our lives easier for OpenStack. Some more simple IPAM enhancements were there. OVN trace continuing to be improved. I mean, like I said before, OVN trace is incredibly helpful. So I think along the way, as it gets used, it starts to become clear which things can be added to make it more useful. One of the big ones was supporting ACLs. So you can imagine a case of, why can't I send traffic to my VM? And so you ask OVN trace, and now it can tell you, well, because your security policy said to drop the traffic. And isn't it nice that you can find it out that quickly as opposed to a lower level mechanism? Another thing that we worked on here for this release was OVSDB role-based access control. So the way OVN controller works is it runs on every host, every hypervisor node or compute host, and they're coordinated by a database. This is the OVN southbound database. We wanted to start locking down what each OVN controller can do with that database, what it has access to in particular, what stuff it's able to modify. And we did that first by adding the ability to define role-based access controls on the database and then giving roles to OVN controllers. So starting to look at an increased focus on the security of the architecture. And then ACL logging. I talked about this earlier when I mentioned ACLs, but this is where it got added in OVS 2.8. And I think I'm pretty excited about that feature. I've talked to multiple people about it. I think it's definitely useful far beyond OpenStack. All right, L3 gateway high availability. So there's a document that I would encourage you to go read if you're interested in this topic. It's in the Open vSwitch docs, and it talks about OVN gateways and high availability and what options we have. So the document actually it's a broader design document of we want to provide gateway HA. What are the different ways we could approach it? And one of the approaches described in there is what actually got implemented. So it does describe that, and the document will tell you what we implemented. But it's a really interesting read. And I don't know if Ethan's here when he wrote that. Just a quick thank you to Ethan for writing it. It made getting this feature built much easier for the team that did it. But the way you configure this is when you define a gateway. Ahead of this, a gateway needs to be bound to a specific host because it's doing NAT. It's stateful. Instead of just defining one host for that, you now define a list of hosts. And you prioritize that list of hosts, and then OVN does the right thing to switch between them as needed to ensure the gateway function is highly available. And the way it does this is each node that may be sending traffic to the gateway is monitoring all of the hosts for that gateway using BFD, and it's going to send the traffic to the highest priority gateway that it can currently reach. And the other thing is the gateways also monitor each other, and based on monitoring each other and their BFD status of hypervisors, they know when they should take over. So kind of glossing over the algorithm a bit here, and we can talk more about it. But I think it gets us in a much better place than we were before, where we literally just did nothing. It was left as an exercise to something outside of OVN to rebind gateways to different hosts if you needed to. But now it's more dynamic and automatic. What happens next? So getting here to what's being worked on. So one is OVSDB clustering. So for the OVN databases, we do HA today. It's active passive, so you have the database, and then you have these read-only replicas that can take over as the new master if you have a failure. But Ben is working on OVSDB clustering, so we'll have an active HA solution for our databases, and you can ask him for more info should you like it. We found some lingering IPv6 gaps that got closed. Justin is working on something to improve the performance of ACL logging because, well, it's a good thing. I expect a lot of focus to be put on control plane performance testing and enhancements, starting to get put more focus in what are the much larger scale targets we want to reach, and what things we need to work on. There are things in this space we know we need to work on, and I'm expecting work to be put there in the coming months. Encryption for OVN tunneling is another area that I expect to put focus on in the coming months. There's patches out for port mirroring that there's been a few revisions of, and also patches for service insertion, at least a simple mode of SFC that have been out and discussed and tested and reviewed for a while. So closing, just back to the perspective, I'm actually feeling really good about where we are. I feel I'm really happy. We've covered like the core requirements, the reusable aspect. We definitely achieved. The things that I feel like are most important are being worked on, and at this point, when features get added from an OpenStack perspective, it's all new value add. We're not in the catch-up mode anymore. It's all about that's a cool new thing, right? That's the best part of the project is we finished the feature parity catch-up, and now we're doing value on top, and that's awesome. I just want to say thanks. I mean, I played a role in this, but I'm just one piece of it, and there's many other people here that have played a role and continue to play a role, and I just want to say thank you for your part in making this a success. On reusability, there's a talk coming up next about container integration. The team from Nutanix is going to talk about their work. There's another virtualization platform called Overt that uses it, and of course we'd like to talk to more. Links to documentation, IRC, and mailing lists, and that's it. Thank you very much.
I think we have time for a question if anybody has one.
Okay.
Is it working?
I was going to try to run away, but I guess I'll take a question.
Thank you so much for your talk. Oh, that was a great talk, and thank you, Lasso. My question is that HA load balancer, and you mentioned about a BPF to check the reachability. Is that mesh-based so that you check all the way, or can you elaborate a little bit more?
Yeah. Okay. L3 gateway HA and how it uses BFD. So all of the hosts that may talk to gateways, they're monitoring the status of all the gateways. The gateways are also monitoring each other. So and there's an algorithm in terms of who can see who. I mean, I think we have like a minute, so I don't know that I.
Thank you so much.
It is documented, though.
It's documented, and I mean, it's not like perfect and it doesn't solve every possible failure, but it solves a lot of them.
We have a source code, right? So.
Excuse me?
Beauty of the open source.
Yeah.
Thank you.
You're welcome.
Sure. One more here.
Sure. Hi there. So as far as IPv6 goes, are you using some combination of DHCP v6 and stateless auto configuration, or how exactly does the IPv6 address assignment story work?
How does DHCP address assignment work?
For v6 specifically.
Yeah. Okay. Well, first of all, I'm not an IPv6 expert. I think so. There is I know we have some DHCP v6 support. That we also do. The logical routers will send periodic router advertisements. Or at least they will or do.
I think
Yeah.
the answer is yes, we support both of those.
Yeah, we support both. There's just like a couple of final patches that I wasn't positive if they had been applied, but
Okay, thank you.
yeah.
If it's a really quick question, go ahead.
There's 8 seconds according to my
The question
timer.
is quick. So, what is your perspective of OVN replacing the reference OVS-based
Yeah.
neutron backend in OpenStack?
So what's my perspective on replacing it? And I don't think replacing it is something that like is just going to be decided. Like it's not going to, that's not how this things go down. What I can say, putting my red hat back on, that's our plan, is that's becoming our default. And that's really how these things change. It's really just, it's less about what a project, there really is no default in it's not like a config file thing that's going to get switched somewhere. It's a question of what are people using and what drives, one of the biggest things that drives what people use is, well, one, how are they getting the system deployed, and how does that, what does the system provide as the defaults? And currently, it's the existing OVS integration is effectively the default everywhere in every OpenStack deployment system. And at least in ours, which I don't know, according to the user survey, I don't know, I'm going to make up numbers, but a large portion, it's going to rapidly switch. As soon as we flip a button, all those people that are just going to take the default are going to be using this. So that's going to be one thing. And then, we'll see where it grows from there. But that's where we'll start to see the biggest change.
All right, let's thank our speaker, and if our